Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. This is Mr. Simon, and we are here to change our world with chemistry. We are still talking about organic chemistry, and we are on Unit 2, that is alkanes. And today, we are going to be talking about the chemical properties of alkanes. So thank you for tuning in. Make sure your book is ready and pen, because today we are going to do some what we call mechanisms. But last time we had said, or we had given you some work to do about writing the isomers we said the isomers of this compound here, C8H18, and we named them. Then we also wanted to choose the isomer that has the lowest boiling point, that has the highest boiling point, and those isomers which form optical isomers, or we can say isomers which undergo optical isomerism. So, yeah, I had tried to do some of them here. We have very many. There are about 18. So we are going to choose one of them which forms. The first question is asking us the one with the lowest boiling point. So last time we were talking about boiling point, and we said boiling point increases as mass increases. Then when we have molecules or compounds with the same molecular formula or with the same molecular masses, they will decrease with increase in branching. So here, if you look at our isomers, we have very many, but the one which is more branched is, I think, this last one here, which is actually 2,2,3,3 tetramethyl butane, and this one will have the lowest boiling point. The lowest boiling point. So the next part of our question was to choose the isomer with the highest boiling point. So according to our field, again, we said branching. As branching increases, boiling point also decreases. So here you'll observe that this isomer here, which is a straight chain, will be the one with the highest boiling points. The highest boiling point. So because for it is not branched, and you have a larger surface area for formation of intermolecular forces, hence the highest boiling point. Then also we have to choose the optical isomers. So our last part of the question is asking about those which form optical isomers. When we are discussing about optical isomerism, we say that those isomers that undergo optical isomerism should have what we call an asymmetrical carbon atom. So among these isomers, we look for those isomers which have the asymmetrical carbon atom. Like, for example, I can give you an example, this one here. If you look at this one, we have a carbon atom here which has 4 different groups attached to it. So this organic compound here, we have said will undergo optical isomerism. So because of the chirocarbon atom. So we can choose another one. Hope you did it. So let's have another one here. Another isomer which has a chirocarbon. If you look at some of these isomers here, let's take an example of this one here. Here, 2,4-dimethyl hexane. Here, we also have another isomer which can form optical isomers. So why? Because it has a chirocarbon atom. Atom. Then another isomer which can form optical isomers is this one. Again, because it has a chirocarbon atom, a carbon atom with 4 different groups attached to it. So we can try to illustrate one of them, like, for example, 2,3-dimethyl hexane. Here we have CH3. So I want to show you the chirocarbon. CH3 we have also have CH. We also have another C. So this C is what we are interested in because it will give us our isomerism. To give us our isomerism. So we can have CH2, CH2, and CH what? 3. 1, 2, 3, 4, 5, 6, 7, 8. So this one. With this group, different from that group, we can consider this one as a group also, then different from that one, and different from this hydrogen. So we can have optical what? Isomers. So quickly, we are going to go and look at our lesson today. Our lesson today. So hope you've got something. So our objective of this lesson is that you should be able to describe the different chemical properties of alkanes. But when we discuss the chemical properties of alkanes, we actually talk about the chemical reactions. Chemical what? Reactions. So we are saying that alkanes are not very reactive. They're not very reactive. But if you look at the first chemical reaction, it is actually very, 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 very useful and very, very important. So our first chemical reaction is the combustion. Combustion. So combustion of alkanes burn in oxygen to give carbon dioxide gas and the steam, or we say water. In addition to that, you will find that we are forming also energy. This is why somewhere when you are discussing about alkanes, we give their uses and we say they are basically used as fuels in the form of gas, especially the ones we normally use at home. So that gas is normally composed of very many alkanes and other compounds, obviously, but especially alkanes. So as alkanes burn in oxygen, they produce carbon dioxide and water like all our organic compounds will do. But in addition to that, they will produce energy. And if it is heating, means this energy will be used in, for example, cooking, for example, in industries, and even in different things like, for example, when you are talking about, you talk about our cars, talk about the vehicles we use in movement, they normally use these fuels. So as they use them, they produce energy. This energy helps in movement of our vehicles and the different cars. So as we have seen, we are saying that as the alkanes burn in oxygen, they will produce carbon dioxide and what? Water. In addition to that, we shall have energy. We shall have what? Energy. Like for example, we say here, we have our alkane, C5H what? So we can use the molecular form, the general formula for alkanes. So 5 times 2 will be 10 plus 2, we have 12. So we add plus what? Oxygen. So what we shall produce here is actually carbon dioxide plus what? Water. Because it is heating, it will be steam. It will be what? Steam. Then we balance our equation. So we have 5 here, carbon atoms, so we put 5. Then hydrogens, we have 12, so we put 6 here. Then we can balance oxygen by putting 5 times 2, which is 10. 10 plus 6 will be 16. So here we put what? 8. So this is 10 plus, so here we put what? 8. So we are saying that this chemical reaction, in addition to producing this, it will produce what? Energy. So energy will be given out to the surrounding. So as this energy is given out to the surrounding, we say this energy is very, very useful in cooking and different applications. So we are saying that these alkanes which have high number of carbon atoms will produce more energy. Will produce more what? Energy compared, for example, to when we have our methane. Our methane. So this methane will also produce the same carbon dioxide as you see on your screen and what? and water, and the water. So we put 2 here. So we put 2 there. Then we say 2 plus 2 will be what? It will be 4. It will be 4. So we put 2 here. So this one will produce more energy compared to this one because obviously the sizes are different. The sizes are different and more energy is evolved here compared to this one. But in addition to that, we should note while cooking that in complete combustion of these compounds or these alkanes will produce carbon monoxide. And this carbon monoxide is bad for our health because carbon monoxide will find its way completely. It will find its way inside our blood and form what we call oxyhemoglobin, which is very, very dangerous and can lead to death. So whenever you're burning alkanes, make sure, or when you're using alkanes for burning, make sure you have enough supply of oxygen. So as we have said, alkanes burn in oxygen to produce carbon dioxide and water. And all our organic compounds will burn in oxygen. Most of them, actually, the ones we shall be talking about, the ones which burn in oxygen, they will produce carbon dioxide and the water. So, but you should note that some of the compounds which we have don't have other compounds like nitrogen, like chlorine. So those ones will give different products, but some of them will not burn. So, but for especially the hydrocarbons, we shall produce carbon dioxide and the water. In addition to that, we shall produce heat, or we shall produce energy, which is very important in cooking and the very many applications, as we shall see when we talk about the uses of alkanes. So quickly, we are going to talk about our reaction number 2, and this is going to take most of our time. So we are going to see that alkanes, despite the fact they are not very reactive, but one of the chemical reactions of alkanes, the few of them, is they have the ability to react with the halogens. They react with what? Halogens. And as you see, we said when you are talking about the reactivity of halogens, we say that the reactivity actually decreases down the group. Why? Because the one which is on top of the group is actually having a very high oxidizing power. So that is the reactivity towards oxidation. So high oxidizing power, and therefore it will react more compared to iodine, which is lower in the group, or lowest, or we can say the least in the group. So despite the fact that we have these chemical reactions, we also show the reactivity of our halogens. So fluorine reacts explosively with alkanes to give a mixture of products, So we may not talk about it, but in addition, one of the products which are produced when fluorine reacts with alkanes is we have HF, we have carbon, and a mixture of different products, which are not actually very, very important. They are not very important. But we are going to discuss about the reaction of chlorine and bromine with the alkanes, because for them they react less explosively, and they are not very, very reactive. They are not very, very reactive, because as you go down the group, reactivity decreases. That is towards oxidation. The oxidizing power decreases. So as you know, fluorine is the one which is the most, or the one which has the highest. We can talk about electronegativity. So we are going to say that chlorine and bromine react in presence of sunlight. In presence of what? Sunlight. Like for example here, we have our methane reacting with chlorine. Methane is reacting with what? With chlorine to produce this compound here, which is chloromethane and HCl. But this reaction is continuous. So you'll observe that this chloromethane can react with chlorine again, to produce again this dichloro what? Methane. So you see that we are having a reaction which we are calling the substitution what? Reaction. So the remaining chlorine atoms again can be removed. They can be what? Removed by reacting with what? With chlorine. Then again the remaining hydrogen again can be removed by reacting with excess chlorine to form carbon tetrachloride. So the reaction is continuous until when all the hydrogen atoms have been replaced. Like when you say a substitution reaction, normally when you say what is a substitution reaction? It's a reaction where we have exchange. Where we have what? Exchange. As you see in our first illustration, you see we have exchange. We have what? Exchange. So our reaction, we shall call it substitution what? Reaction. So a reaction where we have exchange of atoms. Exchange of what? Atoms. So then we can also refer to it as a free radical. Someone may ask himself, what is a free radical? What is a what? A free radical. Do you have someone who knows the definition of a free radical? So actually a free radical, we say, is a highly reactive atom. Highly reactive atom or group of atoms containing a non-paired what? Electron. A non-paired what? Electron. So we have talked about two things. One of them is free radical, another one is substitution. So in this reaction, we shall see these radicals helping in substitution. Hence, we call it a free radical substitution reaction what? Mechanism. So we are going to write the mechanism for our first time. As I told you in our introduction. But let me try to illustrate again more about this substitution. More about this what? Substitution. So we have, let's take an example of our methane. Our methane reacting with what? With bromine. With bromine in presence of UV light. This UV light comes from sunlight. So we have CH3Br. So you'll observe that one of the hydrogen atoms here has been replaced by bromine. So when it is replaced by bromine, we say we have exchange. Have what? Exchange. So the hydrogen which was here will combine with the bromine atom which has not combined with this one to form HBr. So we form our compound we call bromo. We call it bromomethane. Bromo what? Methane. So these are bromomethane. Bromo what? Methane. So the reaction is called substitution. Then when you talk about the mechanism, talk about the what? Mechanism. Talk about the mechanism. The mechanism of what? Reaction. So a mechanism is a system in a way that we show how our products are formed. Or we can say, if it is in mathematics, we can say a working showing how you get your what? Your answers. So this time our mechanisms involves formation of free radicals. As I've told you, free radical is very reactive. So sometimes when it finds its way into our bodies, we can have cancer. We can have what? Cancer. So it's very highly reactive with non-paired what? Electron, as I'm going to show you in my illustration. So we are going to show the mechanism, and we have already named the mechanism. So in the mechanism, we have two things. We have free radical, formation of free what? Radicals. And then the type of our reaction involves substitution. Substitution. So our first mechanism in organic chemistry has 3 steps. So the first step, we call it the initiation step. Initiation what? Step. Initiation. So the first step is called initiation. So in the initiation step, these bromine atoms here will break down to give you 2 of them here. So normally, this dot here is a dot which helps us to know that we have formed a free radical. We have formed a what? A free radical. So we have a non-paired what? Electron there, which forms what we call a free radical. So that non-paired electron, it rotates around its axis and is called a free radical. Then, for example, here, if we have chlorine, we shall have something different. Then let's say our next step will be propagation. Propagation. So in the propagation step, let me not call it step, or let me say step, is our step number 2. So in propagation step, we have one of the radical formed here will combine with the molecule. So propagation step, the radicals combine with the molecules which have not reacted. So in chemistry, when we have a chemical reaction, normally in this chemical reaction, we have many atoms, not as single as we see them here. So when a radical is formed, it can react with any of our compounds. So we shall have CH3 here, have CH3, again also with a non-paired what? Electron plus what? HBr. So meaning that this bromine will remove the hydrogen, then leaving this one a radical. Then this radical here again, which we have formed here, we can put it in front or backwards. It can combine with a fresh bromine molecule. So you see here in propagation, we have molecule, radical, radical, molecule. Then we can form again CH3, Br. So I've showed you this is one of the methods showing us how we produce our products. So we have produced some of them. Then we shall also have, again, so we have HBr. Then we shall have also another what? Radical. So the last step we shall call it the termination. Termination. The termination what? Step. So in the termination step, if you want to get it very well, it's normally a combination of radicals. Any of the radicals which have been formed here can combine and form what we call a product. So let's begin with these two radicals, which will give us our major product or our product of interest. So when you see this dot, it means that they are actually radicals. So we have CH3, B what? R. Then we can also have this one. These ones can combine again with themselves. As I've told you, we have many to form CH3, CH what? 3. We can also have the BRs again combining again. So the reaction I've told you is continuous, and we can form many products. So those are possible products. So as you see, we have the initiation step, formation of radicals, the propagation step where the radical combines with the molecule, any molecule we find. Then termination step, which is a combination of what? Radicals. So these are the 3 stages we are talking about. So let's look at our screen and see what we have again. So this is an illustration again of the first chemical reaction, where we have formation of radicals. The first step in the presence of what? Can put here UV also. Yeah, formation of radicals. Then you see here the molecule combines with the radical to form radical molecule. Then molecule combines with the radical to form molecule radical. Then the last step is combination of what? Of radicals. Combination of what? Radicals. So that is what our mechanism of reaction. Mechanism of reaction. Let's continue with our substitution reaction. So when we have long chain compounds, like for example, longer somehow, like for example propane, we can produce 2 products. We can produce 2 products. As you see, we have chlorine here. It can decide to replace that one to produce 1 chloropropane. Then chlorine again can decide to replace the one in the middle to produce 2 chloropropane. So this substitution here can give 2 products. One we call it major product, another one we call it minor product. When we say minor product in chemistry, we are considering that in this chemical reaction, we are forming 2 organic compounds, ignoring the other one, which is we call the inorganic compound, which is HCl. 2 organic compounds, like for example, 1 chloropropane and 2 chloro-propane. So these 2 organic compounds, if you compare them, one of them will be in larger amount, another one in a small amount. Like in the actual sense, if you look at our real experiment, 2-chloropropane will be 70%, and the 1-chloropropane will be around 30%. That is if you compare it in our percentages. So 2-chloropropane is the major product formed in high amount. Then 1-chloropropane is the minor product, which is formed in very small what? Amount. So here we have 2. So you can decide, or you can do it as a revision, or you can test yourself to see if you can write the mechanism for the formation of the major product. Major what? Product. So let's look at also another illustration here. It is part of our exercise. It's part of our exercise. So the exercise says complete the equation and outline the mechanism for reaction for the major product. So I was saying that you can try this one as your simple homework, trying to write the mechanism of formation of this one, or we can do it in our exercise. Like, let's take an example now. Let me give you a small illustration here. Our number one. Just look here. So we have here butane. Butane is CH3, CH2, CH2, CH what? 3. So that is our butane. Hope you are following and you're enjoying our lesson. So this one will combine with bromine. I'm just giving a more illustration, a more illustrative. So we are saying probably here we can produce 2 products in the presence of UV what? Light. So we are going to have CH3, CH2, CH2, according to our example, CH2. So CH2, one of the hydrogens here will be replaced by what? Bromine. Then we can also have another one, CH3, CH. So in the middle here, we remove one hydrogen and put what? Bromine. So we have CH2 and CH what? 3. Obviously, we have plus what? HBr here. Oh, we have plus what? HBr. Obviously, we have this. So someone may ask you, which one is the major product? So we have said this is the major product. One of the reasons why it is called the major product, because when the bromine atom goes in the middle, the product formed is more stable. So I want you to, the students are going to try out to write the mechanism of formation of this major what? Product. You can even give it a name. Give it a what? A name. So you try out that mechanism. It is free radical. It is in 3 steps, and see if you can be able to test yourself. So another question maybe you can try out is using equations show how the following compounds can be prepared. So here we can use 1 or 2 equations to show how methane is converted to ethane, or how ethane is converted to butane, or how ethene is converted to chloroethane, or how methane is converted to bromoethane. So thank you very much for following me. Hope you followed our lesson today. Make sure you try out the homework as you test yourself. God bless you very much. See you next time.